important and holiest laws in physics is the law of conservation of energy. And what that states is that the total amount of mechanical energy must be constant in a system. And what we mean by that is that whatever amount of energy you start off with, doesn't matter what kind, it could be kinetic or potential, stored or unstored energy, it must equal the amount that you end off with no matter the form. In more simpler terms, or another way to phrase it, is that energy cannot be destroyed. It simply just transforms from one form to another, from potential to kinetic, or from kinetic back to potential. Now, when we use the term potential energy, it's really an umbrella term that represents really any form of stored or unused energy. The most common forms are potential energy, which varies due to height, chemical energy, which is the energy stored in chemical bonds. You have elastic potential energy, which is the energy stored in a substance as it's being stretched or compressed. And then, of course, you have electric potential, which is the energy that converts into usable electrical forms, or electricity, as we would come to understand. Kinetic energy is a little bit more specific, where we're talking about any energy that gets used, and we usually see that in the form of movement, or sometimes heat. Now, some people would question whether energy is fully conserved because they think about a ball that has been dropped. Will it bounce back at the same height? And if it doesn't, isn't that an indication that energy has been not conserved? You're not seeing a contradiction of any kind. All you're seeing is kinetic energy in two forms. When it's at full potential here and then it starts to move, which then it gains kinetic, some of that energy is lost to heat. So you've got potential, gravitational potential over here, then regular kinetic energy, and then that kinetic energy kind of splits into two forms. The one where you could see the movement and the other where it's lost as heat, which is a very specific form of kinetic energy. We can also call it thermal energy. Main point is the total amount of energy is still the same if we were to add all of them up.
Woohoo!
The usefulness of this idea that energy can transform from one form to another can really help us move things that we probably couldn't move very well, even if we applied a whole lot of force. The most obvious example of that would be the car. Imagine trying to push the car with all your might. You might move it a bit, but not enough to get you to the other side of town. But if we can unlock all that potential energy in the chemical bonds of the gasoline through a combustion reaction, well, we see that we can get the car to move quite a lot and quite efficiently. So unlocking potential energy and getting an unused form of energy into more useful forms is one of the things that engineers tend to like to do the most and are probably needed for the most. But I know that this is a lot of talking, and on everybody's minds that's watching this video, we know what you're really thinking. TGIF. Thank God it's a formula. The formula that describes that scenario is this one over here, where the total energy in is equal to the energy out, no matter the form they start or end in. If we're thinking about an object that's being dropped, we have the potential energy as its starting point here. And then that is going to convert to kinetic energy as it falls to the ground. More specifically, our mass times the acceleration due to gravity times the height of the object will equal 0.5 times the mass of that same object multiplied by the speed that it's going. They're going to be equal. One thing that is key to this formula is that we figured out that mass becomes obsolete once it starts moving at constant speed. And so the masses are always going to cancel. So here it says a 0.25 kilogram object is dropped. So that's the key word that tells us energy is being conserved. And that potential energy is equal to the kinetic energy from a height of 3.5 meters. How fast was it going right before it reached the ground? So remember that fast is going to be the speed. So because I know that this is being dropped, we're going to say that your potential energy is going to equal to your kinetic energy. More specifically, mass times gravity times height is going to equal to half the mass multiplied by v squared. And what we want to get is this over here. I've substituted all my values in and I changed the fraction to a decimal to make operations more simple. And then what I'm going to do is I'm going to divide both sides in order to isolate from my v squared by 0.5 multiplied by 0.25. Next, because I want v and not v squared, I'm going to square root both sides in order to remove the square over here. And then when I plug that into my calculator, I get a value of about 8.3 meters per second, and that's when I account for significant digits. An object going at 2.3 meters per second moves up a hill until it reaches its maximum height. What was the max height that it was able to reach at that speed? So in this case, we have a conversion from kinetic energy since it was moving at this speed here. So from kinetic energy to gravitational potential. So what we're going to do is we're going to write our formula. Instead of PE is equal to KE, we're going to go KE, kinetic energy, is equal to potential energy. And we're going to go 0.5 mass times speed squared is equal to mass times gravity times height. Now, it is important to note that we don't have a mass, but since it always cancels out anyway, we can just remove the mass here, and that is not going to matter to us in how we solve this. So now we're going to go and put everything in. So we got 0.5 multiplied by 2.3 meters per second squared, which is equal to, and then 9.81 meters per second squared multiplied by the height, and the height is the unknown here that we're going to solve for. So using a little bit of algebra, we're going to divide both sides here by 9.81 meters per second squared, like so. This is going to cancel out on this side. And after plugging that into our calculator, you get a final height of about 0.27 meters high.